Hi and welcome to the video on permutations. A bag contains 5 balls of different colors: red, yellow, blue, green, and white. In how many ways can these 5 balls be arranged with no restrictions if the yellow ball must be first, if the first ball must not be red or white, if blue and green must be together, and if red, blue, and green must be together? Let's take a look at A with no restrictions. We have 5 selections to be made. When we choose the first ball, we have 5 possible colors to choose from. When we choose the second ball, one is already gone, so we have 4 selections to choose from there. The third, we have 3 selections, 4 we only have 2, and 5 we only have 1 to choose from. Through the multiplication principle for permutations, we know that the total number of arrangements will be 5 times 4 times 3 times 2 times 1. This can be written as 5 factorial, which is a much shorter way, and this is 120. So there are 120 ways of arranging these 5 balls with absolutely no restrictions. Let's look at B. If the yellow ball must be first. Now, if the yellow ball must be first, there's only one way to choose that first ball being yellow. But once the yellow ball is gone, we now have 4 selections for the second, 3 for the third, 2 for the fourth, and just 1 last selection for the fifth. The total number of arrangements will be 1 times 4 times 3 times 2 times 1, which is 1 times 4 factorial. We get an answer of 24 different arrangements where the yellow ball must be first. Let's look at C now. If the first ball must not be red or white, why don't you try pausing the video now and working out what you think the number of permutations is going to be. Okay, the first ball must not be red or white, which means that there are only 3 selections that we can make for the first ball. For the second, once we've chosen the first ball, we have 4 combinations left, and then 3 for the third, 2 for the fourth, and finally 1 for the fifth. The total number of arrangements will be 3 times 4 factorial, which we get as 72. Time for D. If blue and green must be together. If blue and green must be together, we no longer have 5 things to choose from, but 4 different things to choose from. So I'm going to get rid of that last selection. Now, the number of things that can go first are 4. There are only 4 different combinations. I can either choose a red, a yellow, a white, or the blue and green go first. Then I have 3 selections once I've made my first, and then 2 followed by 1. The total number of arrangements is 4 factorial. However, I have a question to ask. Let's look at this particular arrangement. Blue, green, yellow, white, red. And then green, blue, yellow, white, red. Are these 2 different? Well, of course they are. But both of those selections have a blue-green at the start, which means that we have to double all the number of selections that we have so far in order to make sure that we have accounted for the blue and the green changing positions. Now, how do we work out that it's 2? Why is it just 2 because there are 2 things to choose from? Well, not really. We use the same principle for working out the number of arrangements for the blue and the green. The first ball will either be blue or green, so we have 2 selections to choose from. The second ball will either be the other color. So there are 2 factorial ways for every one of those ways of having the blue first followed by the green, or the green first followed by the blue. If we multiply this together, we have 48 different possible permutations. Let's look at a similar one for the last question. If red, blue, and green must be together. Now, if red, blue, and green must be together, that's 1 selection. We have yellow and white to follow. So we don't have 5 selections to choose from now, we have 3. So I'm going to get rid of those last 2 selections. Now, for the first selection, I have 3 possible things that I can choose from. For the second, I have 2. Finally, I have 1. So the total number of arrangements will be 3 factorial. But remember, I have red, blue, and green in individual selections. I need to make sure that I account for every different possible combination of red, blue, and green as well. There are 3 factorial ways of choosing red, blue, and green, so I have to multiply my total number of arrangements by 3 factorial. This means that for the number of selections where red, blue, and green must be together, there are 36. I hope these 5 questions have helped you out with your understanding of permutations. Go back and look at the video again if you still need extra help, or refer to the text. Good luck.